Hi and Assalamualaikum. Today our group want to presenting about paper chromatography in art conservation on subject CHM256. So this is our team members. There are 4 of us, which are Wansar Erdina, Aziza, Nur Nadira and Nur Aimi Amina. And we are from class RAS 1204C. In this video, we have included some agendas such as introduction, methodology, theory and examples, limitation and conclusions, and last but not least, future recommendations and references. Hope you enjoy this video.
Hi, my name is Aimi and I will first present to you the introduction to our topic for this presentation. In analytical chemistry, paper chromatography is a technique for separating dissolved chemicals by exploiting their distant migration rates across paper sheet. This method doesn't require much material and only uses a small amount of sample mixture. Because of this, it has become one of the methods that was widely used to help in identifying the compounds. In art conservation, paper chromatography helps researchers and conservationists in identifying the different layers used in painting so that they can understand how the painting were made before it has to go through a restoration process in order to repair and protect the valuable painting.
Principles of paper chromatography. First, stationary phase. Good chromatography paper is usually used as the good stationary phase in paper chromatography. This paper serves as a medium through which components in a mixture can be separated. Next, mobile phase. A solvent or a combination of solvents travels the stationary phase through capillary action as the mobile phase. It causes different components in the sample to dissolve differently and to move along at different rates. Lastly, partitioning. Compounds are partitioned differently between the stationary phase and mobile phase, which leads to separation. Greater affinity for the stationary phase will cause compounds to move more slowly. Meanwhile, compounds that are more soluble in the mobile phase will go farther. Sample preparation. A tiny sample of the painting, such as a scraping of fragment, dissolved in the proper solvent to remove the binding media. Example of the proper solvent is water, ethanol, or a mixture of solvents. Preparation of chromatography paper. For the procedure, good chromatography paper is selected. To guarantee consistent outcomes, this paper should be in and have an uniform texture. The paper then cut into stripes or sheets at the proper length, usually between 10 and 50 cm and around 2 to 3 cm in width. Developing the chromatogram. A tiny drop of the dissolved sample is put close to one end of the chromatography paper, about 1 to 2 cm from the edge, using a capillary tube or a thin brush. To concentrate the sample in the same area, repeat the method multiple times after allowing the spot to dry. The paper is put in a developing chamber, such as a beaker or chromatography tank, with the sample spot not submerged in the mobile phase, but the bottom edge. When solvent rises up the paper, it carries along the dissolved compounds. Separation of components. As a result of their varying affinities for the paper and the solvent, each component of the binding media will separate. Every element moves at a distinct distance, creating a pattern of spots on the paper. Drying. As soon as the paper is taken out of the chamber, this solvent front's location is marked with a pencil. After that, it is left to dry entirely in a warm air stream or at room temperature. And the last one is visualization and analysis. It can be necessary to use a variety of methods for recognizing the divided components on the paper. Common methods include UV light exposure, staining with specific reagents, or using ninhydrin to detect amino acids. The positions and colors of the spots in the resulting chromatogram are compared to those of reference samples that have been proven to exist.
Okay, so now we move to the theory behind the technique. First of all is capillary action. Capillary action, a process where the solvent flows through the paper's pores against gravity because of surface tension and adhesion forces between the liquid and the paper fibers. Is what pushes the solvent's movement through the paper. The second one is differential solubility. Differential solubility means compounds are separated according to how soluble they are in the mobile phase, as opposed to how much they like the stationary phase. Various chemicals move at various speeds due to this variable solubility. For third, we use retention factor, which is RF. Retention factor means the ratio of the compound's travel distance to the solvent front travel distance is known as the RF value, and it is a key chromatographic parameter. Compounds are identified and compared using it. Okay, so now I'm going to tell you some examples of the binding media. The first example is egg tempera. Egg tempera was made from egg yolk mixed with water and pigment. It dries quickly to a hard and durable finish. It also commonly used in medieval and early Renaissance panel paintings. The second example is casein. Casein is a protein derived from milk mixed with an alkaline substance such as ammonia and lime. It also popular in both ancient and modern art for its matte finish and water-resistant properties once dry. The third example of the binding media is animal glue, or is known as hide glue. It was made from collagen extracted from animal hides or bones, and it dissolved in water. It also used extensively in traditional panel paintings and as a size for canvases. The fourth example is gum arabic. Gum arabic is a water-soluble gum obtained from acacia trees, and it's also frequently used in watercolor and gouache paints. Last but not least is resin, is known as dammer and copper. Usually, resin, natural or synthetic resins dissolve in solvents to create varnishes and mediums. It also used in oil painting mediums and as a final varnish to enhance color and protect the surface. There are four limitations that we have searched for this paper chromatography. Firstly, limited range of applications. While paper chromatography is suitable for separating and analyzing certain classes of compounds, it may not be suitable for all types of analytes. Some compounds may require specialized chromatographic techniques for optimal separation and analysis. The second one is sample size. Paper chromatography typically requires relatively large sample size compared to other chromatographic techniques. This requirement can be a limitation when only small amounts of samples are available.
So in conclusion, paper chromatography is an important tool in art conservation since it allows for exact study of inks, pigments, and dyes. Conservators can expose the composition of ancient artwork by selecting solvents, preparing samples, and also documenting results, which will aid in their preservation and restoration. So this technique contributes to the preservation and celebration of our cultural heritage through continuing improvement and ethical practices. For future recommendations, it is suggested to choose a good water solvent so it can enhance the separations of complex mixture. And choosing a good solvent also is to guarantee a clear separation without chemical reaction. The next one is paper quality. So choosing paper with uniform grain can ensure that it is high in purity and free from contaminants. And selecting paper that is thick and good at handling without tearing. The last one is for effective sample applications. It is suggested to use a capillary tube or micropipette to apply small concentrated spots on the sample multiple times, and this will allow the sample to air dry
are truly a dust-free environment. So regularly practices this technique and use control samples to maintain consistency and precision in applications.